So covered domain decomposition. Now in domain decomposition, uh, so one example I have not explained in that domain decomposition. So as well as this one, the domain decomposition by using the embarrassingly parallel problems. So here, this is nothing but uh, hello, is audible? No, hello. So in this parallel problem here, we need not to synchronize any different threads. So just you can take for this example. Here the one side we are using the processes, and next the in center in embracing the parallel method. So we are using the some unit of the works. Just you can see here, there are the n number of the boxes will be there. Okay, so here, so this is the one of the unit of work. So like that here we are having the separate nothing but all the data stored in the form of the catalogs. So catalogs is nothing but here. So each this unit of the works having the different, like just you can take it as an example, the folders. Okay, so this is unit of the work, and this one folder and next another folder, like that. Here we are using the n number of the unit of the works, nothing but the n number of the folders, like each folder having a different kind of information. Okay, here we need not to synchronize the any different type of threads, means we cannot synchronize the one uh, unit of the work to another unit of the works. Okay, and we do not to share the data, means suppose in this the folder, nothing but this unit of the work having the some information. Okay, the different kind of the information, and this one having the the another kind of the information. For example, just you can take the pen drive. So in that pen drive we are creating the different folders. The first for in that folders, first one is the videos will be there, and some music like audios only, some text, and some important documents and images, photos, like that. So we have created different type of the folders. So we need not to share the some data from the one folder to another folder, like that. So here the each unit of the works, it will not share the any type kind of the data. Okay, this one is this embarrassing parallel problem. This is the quite common. Okay, means just you can base on your assumptions, so it will be works, means here the unit of the work having the number of the iterations. Okay, with help of the decomposition method, how exactly the decomposition method will be works, how exactly it will be works, the decomposition method. Okay, the first the threads identifying the logical sequence of the instructions. Okay, then after using the sequence of the instructions, all the instructions will be executed. So with help of the thread in map. Then like next, just you can use the thread can be you can create or terminate, as well as you can join the all the threads. Then later, the first you can take the code segment. Okay, with respect to the computations to perform. Then later you can take the master thread execution, the first code segment. Okay, the master will be get started, means the thread will be execution will be starts, and they are having the many slaves in that thread. It will be created the execute of respective computations. Then later it will be collect all the results in the where exactly it will collect all the results in slave thread, and the composition of that final result will be performed in the master thread only. Like that, the same here. First you can assume the all the data. This is the totally based on the assumption, and it will be created the iterations, the number of the iterations, and uh, there are n number of the unit of works will be there. Okay, so nothing but just you can create as a iterations, the each unit having the separate, means the different kind of the iterations. Then you can use the decomposition method. Okay, suppose if it is possible, just you can isolate the independent of that unit of the works. Okay, then later you can use the means there are the n number of computations will be there. So which one is there, the high computation? Just you can find out the high computation. Then later, uh, these all the computations will be depends on the values of the iterations. That means highest computation means the each unit having a different kind of, for example, just you can take the uh, so if you are having the 8 GB of the pen drive, means each folder carries the different like size. The videos having the 2 GB, audios 1 GB, like that. They're having the different, the size will be there. Here also the each unit of the works having the different kind of like the first unit, just you can take the 4 MB and second 2 MB, like that. Okay, the each unit having the different size depends upon the computation. Just you can find out the highest value of the computation of the each iteration. Means it will be depend on how many values will be obtained in the previous iteration with help of the decomposition, embracingly the parallel. So just you can go through the second diagram. The first we are using the unit of the works. The each unit of the work depends upon the previous units of the work. The first unit of the work carries the 2 MB. The second example, it will be carries the 4 MB. So the each unit of the works will be depends upon the previous units of the works with help of the embarrassingly parallel method. Okay. The next, with help of the inherently sequential, means here we are using the unit of the works, n number of the unit of the works we are taken. Here also we have taken the processes, the unit of the works and results. So inherently sequential means here also once again we are using like the schematic representation decomposition with help of the same, the both the embracing parallel as well as the inherently, means here we are using the matrix product computation, means each resulting matrix. So with help of we are using here the linear combinations. Okay, the linear combinations with help of like just it is corresponding to the rows as well as columns. Okay, the first and the second input of that matrices with respectively, just you can see here the c of I is equal to the summation the k equal to 0 n minus 1 a of ik and b of kj, like that he has given on equation. Okay, the following that equation, the first one a of ik is nothing but even the embarrassingly the parallel problem, means so just you can take the total number of the processes, the how many unit of the works if you are taking, the each unit of the works is depends upon the previous unit of the works. Then later it will be combines the all the unit of the works and it will be stored in the result. This is nothing but your the a of ik, the b of kj is nothing but here we are using the inherently sequential means here nothing but you are using the some the matrix method. Okay, here just we are using some rows as well as the columns with respectively just we can nothing but the input matrices, it contains the values of the comparable nature with help of the scalar product defined here. Mean nothing but here just you can see that here the unit of the works are different. Here the unit of the works will be the different. Okay, and next the number of the columns of the first matrix must matches the number of the rows of the second matrix. The first matrix rows, it should be match with the number of the rows in the second matrix. The both embarrassingly parallel as well as the inherently sequential. Nothing but here the A of ik is the embarrassingly parallel method and the B of kj is nothing but the inherently sequential. Okay. And just he is using the providing the overview of the mat with help of the matrix product can be performed. Just here we are using for one example. So depends upon the this logical organization. We are using the multi-threads in that program. The each multi-threading program having some steps will be there. The first you can perform the computation the same as the previous embarrassing parallel method. Computation is each unit of the works having the different kind of the information depends upon the previous one. Means like that it will be same, it will be perform the computation of the single elements. So with help of the resulting matrix of the implementing the previous equation, means the each unit of the works, it will be depends upon the previous the unit of the work, nothing but the like that summation of I equal to 1 equal to n minus 1 a of ik equal to b of like that one equation will be there. The same, the previous equation will be worked with help of the performance computation. Next one is the create the double loop. Creating for the double loop is nothing but the first you can take the index iterations of the iterations of the all the rows and the first matrix, and the second just you can take the column of the second matrix. The first you can take the only rows, okay, the first matrix, and the second just you can take the columns of the second matrix. Then you can compute that thread, then resulting matrix it will be like, for example, suppose if you're using the 4, just you can see here the 4 cross 6 is there, 6 cross 3 is there. So finally we'll get the 4 cross 3 the matrices. And next join the all the threads. Okay, here just you can a b c three threads will be there, and 4 cross 6 6 6 cross 3, and we have finally we got the 4 cross 3. So you can join the all the threads. Okay, after joining the threads you can compose this resulting matrix. Okay, here the 4 cross is the 4 and 4 and 6 6, okay, 3 3. After joining these all things the a and b, so you will get the 4 cross 3. This is nothing but the resulting matrices. This is one of the example by using the uh, decomposition method. So in that decomposition method, first we are using the embarrassing parallel method, and second was inherently sequential. Means just you can say the here the we are using n of the unit of the works, the processes and resulting will be using, and here also the we are using same the processes as well as the resulting. Here only we are applying the matrices methods with help of the rows as well as the columns. And next one is the computational, sorry, the functional decomposition. Functional decomposition, nothing but this is a process of identifying the function, like functionally distinct but independent computation. Functionally distinct but independent computation, nothing but just here, here he is focusing on the type of the computations. Okay, after finding the all the computations, uh, then later all the data will be manipulated or not, he will check like that. It means suppose here in this diagram we are using the n number of the unit of the works. Then in that process we are using the combinations, the squares, the rectangles, and so here we are using the squares, rectangle, and like that here we are using the different shapes. And next in this middle we are using the some unit of the works, and in the after combining these all unit of the works we will get the result. So each unit carries the different type of the symbols, means the shapes, the square is there, rectangle is there, the, like that here where you each unit carries the different type of the informations. Okay, the functional decomposition is nothing but the mostly this one is uh, used in the project analysis phase. Okay, how exactly the process project analysis phase it will be works. It will produce the functional decomposition diagram. Okay, how exactly the identifying the all the requirements of the, like, for example, if you have drawn any diagram. Okay, uh, in a project analysis phase, in that project analysis phase, it will produce the decompose, we are having one decomposition diagram. So in that decomposition diagram, so what are requirements of our project, we can easily find out all the requirement uh, of the our project, like we can find out easily with help of the functional decomposition. So after, suppose if you are using the in with help of the decomposition method, uh, First, you can find out the total number of the levels in that components in that functions. Next, you can continue the decomposition from the lower level until the sufficient level, means after completion of means you can use start from your project initial stage to after completion of your project, means from first phase to you can use up to the end of your project phase. All phases you can use this the functional decompositions, and then next it will be perform the end to end, like means it will be give the all the information. Means for example, if you are using the different like modules, so if you are using the with help of the some flow diagrams and some data flow diagrams and like some architecture, so we can easily find out the all the modules, means the how many models will be there in your project, so we will get the all the information. So that's why we're using here the functional decomposition. It will be check the all the functions, means it will be for for example, in your project we are having the five models. The each module will be like working, all the functions will be working correctly or not. We can easily find out the all the functions with help of the functional decomposition. Okay. And next, in the functional decomposition, this is nothing but here we are using the natural decomposition. Means with help of the natural decomposition, the problem will be separates the unit of the works. So just you can see here diagram. The first, I'm using the processes. In that processes, we are having the combinations. Okay, so you can take the n number of the like shapes here. Then after, I'm applying here the functional decomposition, nothing but the natural decomposition. After applying the natural decomposition, so automatically so all the processes will be separates the units of the works. Okay. After separating the unit of the works, uh, after applying only the decomposition, then it will be separated. After separating, so all the unit of the works will be sent to the resulting whatever the result means. After the process first phase the process, then unit of the works, means with the help of the applying the decomposition method. After applying the decomposition means automatically that all unit of the works will be separated, means it will be created a separate of the unit of the works. After creating the separate of unit of the works, then just you can use the functional decomposition. After applying that functional decomposition, it can be required the means how many the composition phase it will be required, like depends upon the each unit of the works. So it will be like how many requirements, means how many require the composition phases in the each unit of the works. Outcome means the each independent works how to compose together, means after the process, in the process it will be combined, and after combining just I'm applying the decomposition method. After applying the decomposition method, the each or unit of the works will be getting separate, means the unit 1, unit 2, unit 3, 4 and unit 5. And later once again I'm applying the subjected functional subjected function subjected function is nothing but here the with help of the functional decomposition, just you can apply the functional decomposition method. So it will be find out in requirement of the how many the composition phase will be required. So it will be check out. After checking the composition phases, then depends upon that outcome, the composition phase outcome. So each independent of the unit of the works will be works together, means here we're using the some simple mathematical problem with help of the embarrassing parallel method using the functional decomposition. So here we need to calculate the function of the all the functions, nothing but all the unit of the works, the values x, means the each how many. Here I'm using the 5 unit of the works. So the how each unit of the work carries how many values of x. Okay, then how to find out the values of the x. The values of x is nothing but the set. Okay, here we are using the three different operations. It can be performed independently. Here we are using three different like operations. Okay, each operation should be performed independently each other. Okay, Then in this functional decomposition, you can so entire problem will be divided into three distinct operations. That one is nothing but sine, cos, as well as the tan. Okay, so how to find out the functional decomposition of the each unit of the works? So x is nothing but the set. Okay, the value set. Then how to find out f of x equal to sine x plus cos x plus tan x, means in whole functional decomposition method. So three distinct operations. Distinct is nothing, means we are using the sin x on is one separate function, cos x and tan x, means independently these all operations will be works in this unit of the works. After whatever the f of x we will getting, no, that all the result will be stored in here in this first the processes. Then here we are applying the decomposition method. After applying the decomposition method, once again it will be creating the separate units. After creating the separate units, once again I am using applying the functional decomposition method. So it will be find out in the requirements of the like the composition phases, means how exactly the each unit of the works independently working. After composing, how exactly whatever expected output we will get. Then after I'm applying the functional decomposition with help of the mathematical function. Then how to find out is the f of x values. X is nothing but the set of the values of the set of the values, means nothing but after combining the unit of 1, unit 2, 3 and 4 and 5, we will get is the set of the function of value, nothing but the total unit of the works. Okay, then how to find out the total unit of the works? So with help of the f of x equal to sin x plus cos x plus tan x, you will get the total decomposition, function decomposition. Okay, the next one is the computation versus the communication. So normally the communication is common here. Communication is talking from you can talk with one person to another person. Nothing but this is the communication. Here also same statement here is using communications. Nothing but here with help of the decomposition method here used. So one method is embarrassing parallel method, and another method is the inherently sequential method. We are using the two methods here. So the two method will be communicated in means it will be like synchronizing from one embarrassing method to inheriting method. So with help of the matrices. So just you can take the embarrassing set is the A and the inheritance sequence is the B. So we will get the final the resultant matrix. So A cross B, you will get the one result. This is nothing but the communication. Just he has taken one example for the communication. And next just how exactly the communication method will be works with help of the decomposition as well as domain decomposition as well as the functional decomposition. So here we use the two composition methods. That one is the functional as well as the first one is the embarrassing parallel method as well as the inheritance sequence method. This is the one, and second is the functional two decomposition method corresponding to that decomposition method. Just you can assume the how many computation of the means computation means how many unit of the works will be working independently. Okay, with help of the just you can take the one input value. Just after combining the embarrassing method as well as its inheritance sequence, just you can give the one input values. Okay, it will be required with some one computations and do not depends upon the output value generated by the another computation, means own embarrassing as well as the inherently own, it will be generated the one output not it will depends upon the unit of the works, means here we are using the total n of the units. It will not depends upon the one previous. See normally in the embarrassing method, so the each unit of the works it will depends on the previous unit of the works, but here it will be not depends upon the previous unit of the works. How many unit of the works will be there, it will be combined the unit of the works, then finally it will be get the f of x equal to sin x cos x as well as tan x, we will get the result. Okay, and next you can different, suppose if you have taken the different unit of the works, okay. Suppose normally in the year, in this examples he has taken the same unit of the works. Suppose if I taken the different unit of the works, okay, in that case it will be generated a result, like how exactly how it will be generated a result with help of the decomposition. Here it will need not to interact, means it will not exchange the data from the one unit of the works to another unit of the works. How exactly the data will be there from the one unit of the one first unit, second unit, third unit, fourth unit, and fifth unit. As it is, the result will be displayed. It will not share the not exchange any data from the one unit to another unit. Okay. How exactly if you're like from process to unit of the works, if you're sending the data, so as it is, it will be displaying in the result. Suppose if you're using inherently as well as embarrassing method, then only it will compare to the last unit of the works, then finally it will combine the all the unit of the works, then it will be sent to the result. Okay.